Saturn, the ringed giant. Introduction. Saturn is the sixth planet from the Sun and the second largest planet in our solar system, after Jupiter. Known for its breathtaking ring system, Saturn has fascinated astronomers and cultures for centuries. It is a gas giant with a unique blend of mystery, beauty, and scientific importance. Basic facts about Saturn. Size and dimensions. Diameter approximately 120,536 kilometers, 9.5 times Earth's diameter. Saturn is the second largest planet in the solar system after Jupiter. If Earth were the size of a nickel, Saturn would be about the size of a volleyball. Circumference at equator 378,675 kilometers. That means you'd have to travel more than 9 times around Earth's equator to match one trip around Saturn. Mass and density. Mass, about 95 times that of Earth. Density, only 0.687 grams per cubic centimeter less than water. This makes Saturn the least dense planet in the solar system. If there were a giant cosmic ocean big enough, Saturn would float in water. Time measurements. Length of a day. Rotation, approximately 10.7 hours. Saturn spins very fast on its axis, much faster than Earth. This rapid spin causes the planet to bulge at the equator and flatten at the poles. Length of a year. Revolution, approximately 29.5 Earth years. Saturn takes nearly 3 decades to complete one orbit around the Sun. This slow orbit means Saturn stays in one zodiac sign for 2 to 3 years, which is why it's so important in astrology. Distance from the Sun. Average distance, approximately 1.4 billion kilometers, 9.5 astronomical units. 1 AU equals distance between Earth and Sun. 150 million kilometers. Light from the Sun takes about 80 minutes to reach Saturn, compared to only 8 minutes for Earth. Temperature and climate. Average temperature, minus 178 degrees Celsius, menos 288 F. Saturn is an icy cold world with no solid surface. Temperatures vary depending on depth in the atmosphere. Upper atmosphere, extremely cold. Deeper layers, much hotter due to high pressure. Atmosphere. Saturn's atmosphere is made mostly of hydrogen, 96% helium, 3% traces of methane, ammonia, and water vapor. Features powerful storms, including the famous hexagonal-shaped storm at the North Pole. Gravity. Surface gravity, 10.44 meters per second squared, approximately 1.07 times Earth's gravity. If you weigh 100 kilograms on Earth, you'd weigh about 107 kilograms on Saturn, ignoring that you can't really stand there. Orbit and tilt. Orbit, almost circular, but slightly elliptical. Axial tilt, 26.7, similar to Earth's 23.5 tilt, closing parenthesis. This means Saturn experiences seasons, but they last more than 7 Earth years each, due to its long orbit. Visibility from Earth. Saturn is visible to the naked eye as a bright, golden yellow star-like object. With a small telescope, its famous rings can be seen, making it one of the most breathtaking objects in the night sky. Saturn is a giant, low-density, cold, and fast-spinning planet with stunning rings. It is the least dense planet, takes 30 years to orbit the Sun, has a 10-7-hour day, and is made mostly of hydrogen and helium. Structure and composition of Saturn. Internal layers of Saturn. Atmosphere. Outermost layer, composed mostly of hydrogen and helium, contains cloud layers made of ammonia, ice, upper, ammonium hydrosulfide, middle, and water, ice, lower. Cloud bands run parallel to Saturn's equator, similar to Jupiter's. Features storms, cyclones, and jet streams with winds up to 1,800 kilometers per hour, 1,100 miles per hour. Molecular. Hydrogen layer. Beneath the atmosphere lies a vast ocean of liquid hydrogen. This layer transitions slowly from gaseous hydrogen above to liquid hydrogen below due to immense pressure. Metallic hydrogen layer. At very high pressures, hydrogen behaves like a metal conducting electricity. This layer is responsible for Saturn's magnetic field. core believed to be made of rock, metals, and ice, estimated to be 10 to 20 times the mass of Earth, extremely hot up to 11,700 degrees Celsius. Bain-Tuno-Meal, if the core generates heat through slow gravitational compression, Kelvin-Helmholtz mechanism, making Saturn emit more energy than it receives from the Sun. Atmosphere, in detail composition, 96% hydrogen, 3% helium, traces of methane, ammonia, and water vapor. Temperature range, upper atmosphere, minus 178 degrees Celsius average. Deeper layers, much hotter. Special feature, the hexagon, storm at the North Pole. A giant, six-sided jet stream, about 30,000 kilometers across, discovered by Voyager in the 1980s, still active today. Shape and rotation: Saturn is an oblate spheroid, wider at the equator, flattened at the poles, caused by fast rotation, 10.7 hours, day, and low density. Equator bulges outward approximately 10% more than polar diameter. Summary of structure: Saturn is a planet with no solid surface. It is a giant ball of hydrogen and helium with layers transitioning from gas, gives liquid hydrogen, gives metallic hydrogen, gives dense rocky, icy core. Its atmosphere hosts storms, powerful winds, and the famous polar hexagon. Saturn's rings overview. Of the rings, Saturn's rings are the largest and most spectacular ring system in the solar system. They are made up of billions of particles, ranging in size, from tiny dust grains to house-sized boulders. The rings stretch over 280,000 kilometers. In diameter, almost 3/4 of the distance from Earth to the Moon. But they are incredibly thin, only 10 to 100 meters thick, on average. Composition: the rings are 90 to 95% water ice, mixed with rocky dust and organic molecules. Their brightness comes from the high amount of ice, which reflects sunlight. Origin theory: scientists are not completely sure how Saturn's rings formed, but there are two main theories. Destroyed moon theory. A moon came too close to Saturn and was torn apart by tidal forces. Roche limit. Primordial material theory. Leftover icy material from Saturn's early formation that never formed into moons. Division of the rings. The rings are grouped into 7 major sections, labeled alphabetically in the order of their discovery. D ring, innermost, faint and hard to see. C ring, called the crepe ring, thin and faint. B ring, brightest and most massive ring. Cassini division, a large dark gap, approximately 4,800 kilometers wide, between the A and B rings. A ring located outside the Cassini division contains the ENC gap. F ring, narrow, braided, and influenced by small shepherd moons. G and E rings, very faint, outer rings. The E ring is fed by geysers from Saturn's moon, Enceladus. Shepherd moons, small moons, like Prometheus, Pandora, and Daphnis, orbit near or within the rings. They act like shepherds, using their gravity to shape and maintain the ring edges. Age of the rings. Earlier theories suggested the rings were as old as Saturn, 4.5 billion years. New evidence from the Cassini spacecraft suggests they may be young, only 100 to 200 million years old, formed around the time of the dinosaurs on Earth. The rings may eventually disappear as material falls into Saturn. Saturn's rings are a majestic, icy system, thin, wide, and dynamic. They are shaped by shepherd moons, divided into 7 groups, and possibly much younger than the planet itself. Saturn's magnetic field. Saturn's magnetic field. Saturn's magnetic field is generated by metallic hydrogen deep inside the planet. As hydrogen is compressed under extreme pressure, it behaves like an electrically conducting liquid metal, creating a dynamo effect. Strength. Saturn's magnetic field is about 578 times stronger than Earth's, but still weaker than Jupiter's. Its field is highly symmetrical around its rotation axis, unique compared to other planets. Extent. The magnetosphere region controlled by Saturn's magnetic field extends up to 1-2 million kilometers toward the Sun and stretches beyond the orbit of Titan on the far side. It forms a giant protective bubble that shields Saturn and its moons from the solar wind. Radiation and particles radiation. Belts like Jupiter and Earth. Saturn traps charged particles, protons, electrons, ions within its magnetic field. These belts are not as intense as Jupiter's, but still dangerous for spacecraft and electronics. Auroras. Saturn's magnetic field interacts with the solar wind, creating beautiful auroras similar to Earth's northern lights. These auroras appear as glowing ovals near the poles, observed in ultraviolet and infrared light by the Hubble Space Telescope and Cassini spacecraft. Ring and moon interactions. Saturn's rings and moons interact with the magnetic field. For example, Enceladus ejects water particles into space through geysers, which become ionized and trapped in Saturn's magnetic field, feeding its radiation belts. Importance of Saturn's magnetosphere protects Saturn's atmosphere from being stripped away by the solar wind, helps create the planet's spectacular auroras, provides clues about the internal structure of Saturn, since the field is generated deep inside, affects habitability potential on moons like Titan and Enceladus, since the radiation environment influences surface and subsurface chemistry. Saturn's magnetic field, though weaker than Jupiter's, is still powerful and unique for being nearly perfectly symmetrical. It shapes the planet's magnetosphere, traps radiation, powers auroras, and interacts with its rings and moons. Moons of Saturn. Overviews. Saturn has 145 confirmed moons, the most of any planet. They range from tiny asteroid-like bodies, only a few kilometers wide, to giant worlds larger than Mercury. The moons play a key role in shaping Saturn's rings, magnetosphere, and even its habitability potential. Major moons of Saturn. Titan, the largest moon diameter, approximately 5,150 kilometers larger than Mercury. Atmosphere, thick, mostly nitrogen, 95%, with methane clouds. Surface, lakes and rivers of liquid methane and ethane. Icy crust. Importance, considered one of the best places to search for life beyond Earth. Exploration. The Huygens probe 2005 landed on Titan, the first landing in the outer solar system. Future mission. NASA's Dragonfly mission, planned 2030s, will send a drone to explore Titan's surface. Enceladus, the icy ocean world size, small to 500 kilometers diameter, famous for water geysers erupting from cracks in its icy crust. Subsurface ocean, strong evidence for a global saltwater ocean beneath the ice. Habitability, contains water, organic molecules, and energy, making it a prime candidate for alien microbial life. Cassini discovered plumes that contribute material to Saturn's E-ring. Mimes, the Death Star, moon diameter, approximately 396 kilometers. Notable feature, huge impact crater, Herschel crater, gives it a resemblance to the Star Wars Death Star. Mostly icy, heavily cratered surface. Iapetus, the Yin-Yang moon diameter, approximately 1,470 kilometers. Unique two-tone coloration, one side bright white ice, the other dark brown/black dot, has a mysterious equatorial ridge mountain chain running around much of the moon. Rio diameter, approximately 1,528 kilometers. Second largest Saturnian moon after Titan, mostly ice and rock, heavily cratered. Dione diameter, approximately 1,120 kilometers, shows bright wispy terrain, thought to be ice cliffs. Tethys diameter, approximately 1,062 kilometers, dominated by a massive canyon system. Ithaca, Chasma. Hyperion diameter, approximately 270 kilometers, irregular sponge-like shape with extremely low density. Phoebe diameter, approximately 213 kilometers. Retrograde orbit, opposite Saturn's rotation, likely a captured object from the Kuiper belt. Role of moons in Saturn's system. Shepherd moons, tiny moons like Prometheus and Pandora, help shape Saturn's rings. Titan and Enceladus, critical in the search for life. Moons and rings interaction. Enceladus feeds the E ring with its geysers. Saturn's moons are like a mini solar system. From Titan's methane rivers to Enceladus's water geysers and Iapetus's two-tone surface. They represent some of the most exciting worlds for exploration and possibly even extraterrestrial life. Exploration of Saturn. Early observation has been visible to the naked eye since ancient times. Galileo 1610 first observed Saturn with a telescope but thought the rings were ears or handles. Christian Huygens 1655 correctly identified the rings and discovered Titan. Giovanni Cassini 1675 discovered the Cassini division, the gap between Saturn's A and B rings. Spacecraft missions to Saturn. Pioneer 11 1979, first spacecraft to fly past Saturn, discovered new moons, details of Saturn's magnetic field, and gave the first close-up images of the planet and rings. Voyager 1 1980 and Voyager 2 1981 flew by Saturn, providing spectacular images of rings and moons. Voyager 1 discovered details of Titan's thick atmosphere. Voyager 2 provided closer views of moons like Enceladus, Iapetus, and Tethys. Both missions expanded our knowledge of the complex ring system. Cassini-Huygens mission 2004 to 2017 joint mission by NASA, ESA Europe, and ESA Italy. Cassini orbiter studied Saturn, its rings, and moons for 13 years. Huygens probe landed on Titan in 2005, the first landing in the outer solar system. Discoveries. Enceladus has water geysers and a subsurface ocean. Titan has rivers and lakes of methane, ethane. Detailed images of Saturn's storms, hexagon cloud, and ring dynamics. Grand finale, 2017. Cassini was deliberately plunged into Saturn's atmosphere to avoid contaminating moons that may harbor life. Future missions. Dragonfly mission. NASA planned launch 2027, arrival 2034. A nuclear-powered drone to explore Titan's atmosphere, surface, and organic chemistry, will search for prebiotic chemistry and conditions for life. Proposed missions include probes to explore Enceladus's geysers and search for signs of microbial life in its ocean. Asterisk. Importance of exploration revealed Saturn's system as a miniature solar system with active moons, showed Saturn's rings are dynamic and possibly young. Raised Saturn's moons Titan and Enceladus as prime targets in the search for extraterrestrial life. From Pioneer and Voyager to Cassini-Huygens, every mission has revealed Saturn to be far more complex and fascinating than imagined. With future missions like Dragonfly, Saturn will continue to be at the center of planetary exploration and the hunt for life. Asterisk. Importance of Saturn in the solar system. Gravitational influence. Saturn is the second largest planet in the solar system, with a mass 95 times that of Earth. Its huge gravity helps shape the orbits of asteroids, comets, and smaller moons. Acts like a cosmic guardian, deflecting or capturing objects that might otherwise threaten the inner planets, including Earth rings. As a natural laboratory, Saturn's rings provide an opportunity to study planetary formation processes. The way particles in the rings collide, cluster, and interact with shepherd moons gives scientists clues about how planets and moons form from disks of dust and gas. Moons in the search for life. Titan and Enceladus are among the most promising worlds in the solar system for finding signs of life. Enceladus has liquid water, organic molecules, and energy, the key ingredients for habitability. Titan has complex, organic chemistry, possibly resembling early Earth before life began. Saturn's magnetosphere. Saturn's strong magnetic field creates a protective bubble against the solar wind. This magnetic environment influences its moons and can even generate auroras that help scientists study interactions between magnetic fields and atmospheres. Role in planetary science. Saturn is an example of a gas giant with extreme features, rings, powerful storms, rapid rotation, and unique magnetic properties. Studying Saturn helps scientists understand not just our solar system, but also the many giant exoplanets scattered around other stars. Cultural and scientific significance. Saturn has inspired human imagination for thousands of years. Its presence in astrology symbolizes time, discipline, and cycles. In astronomy, Saturn's system has been crucial for testing new ideas about planetary science, atmospheres, and potential life. Saturn is not just a beautiful planet with rings. It is a guardian of the solar system, a laboratory for planetary formation, and home to moons that could harbor life. Its importance lies in both protecting Earth and advancing our understanding of the universe. Saturn in mythology and culture. Saturn in mythology. Roman mythology. Saturn was named after the Roman god Saturnus, the god of time, wealth, agriculture, and renewal. He was considered a powerful deity who ruled during a golden age, when people lived in peace and abundance. The festival Saturnalia, held in December, honored him with feasting, gifts, and role reversals. Many of its traditions influenced later Christmas customs. Greek mythology. The Roman god Saturn corresponds to Cronus, the leader of the Titans. Cronus overthrew his father Uranus, but was later defeated by his own son Zeus. Jupiter. This myth reflects Saturn's slow orbit time and cycles and its connection to discipline, endings, and rebirth. Hindu mythology and Vedic astrology. Saturn is known as Shani, one of the Navagraha 9 planetary deities. Shani is associated with justice, discipline, karma, and hardships. Worshippers believe Shani's influence can bring challenges but also spiritual growth and wisdom. Saturn in astrology. Saturn represents time, responsibility, discipline, and boundaries. Known as the taskmaster planet. It brings lessons through challenges. A person's Saturn return, every approximately 29.5 years, is considered a major turning point in life, symbolizing maturity and transformation. Saturn in culture and symbolism. Art and literature. Saturn has appeared in countless paintings, poems, and stories. For example, Francisco Goya's haunting painting Saturn devouring his son represents the myth of Cronus. Science fiction. Saturn and its moons often appear in sci-fi works as mysterious destinations. Titan, in particular, is a popular setting due to its Earth-like atmosphere. Modern symbolism. Saturn's rings symbolize eternity, cycles, and beauty, making the planet an icon of cosmic mystery. Saturn is more than a planet. It is a symbol of time, karma, discipline, and renewal in myth and astrology. Across cultures, it represents both challenge and wisdom, shaping human imagination for millennia. Saturn in the solar system. Saturn is not just another gas giant. It is a cosmic masterpiece. From its dazzling rings to its mysterious moons, Saturn continues to surprise scientists and inspire human imagination. Its rings are the most spectacular structures in the solar system. Its moons, especially Titan and Enceladus, may hold the secrets to life beyond Earth. Its magnetic field, storms, and winds showcase the raw power of nature on a massive scale. Its role as a gravitational giant helps shape the solar system's balance. Saturn stands as both a guardian and a laboratory, teaching us about planetary systems, cosmic beauty, and the possibility of alien life. Why Saturn matters for scientists? It is a key to understanding giant planets and exoplanets beyond our system. For dreamers, it is a symbol of time, mystery, and beauty, seen in mythologies and cultures worldwide. For humanity's future, its moons could one day be stepping stones in space exploration, and perhaps even places for human colonies. All planets in the solar system, in order from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Saturn is the jewel of the solar system, a planet of rings, storms, and mysteries. From the ancient myths that named it after the god of time, to modern space missions that revealed its icy moons and glowing auroras, Saturn continues to be a planet where science meets wonder. It reminds us how vast, beautiful, and full of secrets the universe truly is.